jungle. We've got fun and games. We got everything you want, honey. We know the name.
So where we left off in Unit 4 was taking a look at a curve. And we'll call this curve f of x. And let's say we have some point P on the curve. This point P is at the point x and f of x. And in Unit 4, if we wanted to find the slope of the tangent to this curve at point P, we would take another point, Q, and point Q was some distance, some horizontal distance h away from point P. And so our point Q we could say is at the point x plus h and the y value of f of x plus h. And to find the tangent at point P, we were minimizing the value of h. We were trying to make h as close to 0 as possible. So to find the slope of f of x at point P, we use the equation, the limit as h approaches 0 of f of x plus h minus f of x all over x plus h minus x. And this is from the equation for slope, y2 minus y1 over x2 minus x1. So f of x plus h is our y2 value, f of x is our y1, x plus h is x2, minus x represents that x1 point. And we simplified this equation in Unit 4 to the limit as h approaches 0 of f of x plus h minus f of x all over h. And this limit statement can also be written as f, the little dash above the f, of x. And that little symbol is read as prime. So if we're finding the slope of a tangent to a curve at a certain point, we're using this limit function. We can call it f primed of x. And this limit function what we call first principles finds us the slope to a curve at any point. So the derivative function called f primed of x is a function that gives as its y value the slope of the tangent line to a curve at any specific x value. So the derivative f primed of x, or more simply just f prime, gives us a function that tells us the slope to a tangent of a curve at any point. So let's look at an example of this. For the equation f of x equals the square root of x, let's use first principles to find the derivative. And when we're finding the derivative, we're finding that function f primed of x. So f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. We know f of x is the square root of x, so we can sub some things in here. The limit as h approaches 0 of the square root of x plus h minus the square root of x all over h. Now we're working with a limit problem that we want to simplify, and to simplify this I'm going to multiply top and bottom by the conjugate. So when I do that, I end up with x plus h minus x in the numerator, and in the denominator don't multiply this out, h times the square root of x plus h plus the square root of x. So I can simplify things now. My x's in the numerator cancel, so I have h over the denominator. I can cancel out the h's in the numerator and the denominator, leaving me with the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. If I then sub in h equals 0, I end up with 1 over the square root of x plus the square root of x, which becomes 1 over 2 times the square root of x. So I can summarize this and say that the derivative function f prime of x is equal to 1 over 2 times the square root of x. And as a rule of thumb, we don't rationalize derivatives. So this function, f of x, represents the slope of our original function at any given point. So if I wanted to find the slope of the tangent to f of x at x equals 9, I can take my derivative function, f prime of x equals 1 over 2 root x, and I can evaluate f prime of x. I can evaluate f prime of x at 9. So I'd have 1 over 2 times the square root of 9, which becomes 1 over 2 times 3, or 1/6. So the slope of this square root function at x equals 9 is 1/6. So all I really wanted to do in this video was define what a derivative is and show you how we can find it. And I think I've done that in just a quick example. In class tomorrow, we're going to do a lesson on finding derivatives for other functions and start to look at shortcuts, because I think we can all agree, as neat as this limit equation is, it does become cumbersome to use, especially for more complicated functions. So we do want to start finding some shortcuts, and we'll do that in class tomorrow. Thank you for watching. Have a good night.